Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. In this lecture, I am going to cover linear differential equation of second order, which is having non-homogeneous terms of type 3 and type 4. To find the particular integral where the function is of x power n, so we have to write this in the expression using binomial theorem. So we have to apply any one of these formulas where capital D means d by dx, right? We have to write the given function in this form: 1 plus or minus some function of d whole inverse, or 1 plus x whole in or minus 2, or 1 minus x whole power minus 2, and apply these formulas. Let us solve this. This can be written as d square minus 1 into y is equal to 5x minus 2. Now this is in the form of f of d into y is equal to 5x minus 2. First let us find the complementary function yc. For that we require auxiliary equation given by f of m equal to 0. So m square minus 1 equal to 0. So m square equal to 1. So m is equal to plus or minus 1. Minus 1 and 1 are the two roots which are real and distinct roots, right? So yc we write it as c1 e power minus x plus c2 e power plus x. Now let us find the particular solution or particular integral yp or pi, which is particular integral 1 by d square minus 1 5x minus 2. So this can be written as 1 by 1 minus d square, taking minus common, 5x minus 2. So minus this 1 by 1 minus d square can be written as 1 minus d square whole power minus 1 into 5x minus 2. So minus of 1 minus d whole inverse, we have the formula 1 minus d whole inverse equal to 1 plus, we have to apply this formula 1 plus d square plus d cube plus and so on. Plus and so on means up to how many terms? Here we have to see the function given. This is a first degree polynomial, right? So we have to write only up to the terms which is containing d terms. No need to write d square, because derivative of x is 1. If you differentiate this 2 times, capital D square of x square means constant derivative 0, d cube of x cube means 0, and all higher order derivatives will become 0. So we get this as minus of 1 plus d square plus d square whole square plus d square whole power 3, all powers higher order derivative will become 0. So write only up to here. So minus of 1 into 5x minus 2 plus d square of 5x minus 2 is, first you differentiate for one time, that is 5. So again if you differentiate, you get constant derivative 0. So we get only this, that is 2 minus 5x. Therefore y is equal to yc plus yp. Add this complementary function and particular solution, we get the general solution, right? Let us see one more example. Solve d square minus 3d plus 2 into y equal to 2x square. First let us, this is in the form of f of d into y is equal to 2x square, right? So what is the auxiliary equation? Which is given by f of m equal to 0. That means m square minus 3m plus 2 equal to 0. So there will be two roots for this equation. Let us find those, which can be written as m minus 1 into m minus 2 equal to 0. So there are two roots, m is equal to 1 comma 2. Both the roots are real roots and different roots. So how to write down the complementary function? Yc is equal to c1 e power 1 into x plus c2 e power 2x. Let it be equation 1. Now to find the particular integral yp or pi 1 by f of d square minus 3d plus 2. The function is 2x square. Now let us take the constant common in the denominator, which can be written as 2 into 1 plus d square minus 3d by 2, and the function is 2x square. Of course 2 and 2 get cancelled. This can be written as 1 plus d square minus 3d by 2 whole inverse into x square, right? Now this is in the form of 1 plus d whole inverse, and the formula is 1 minus d plus d square minus d cube plus and so on. Here the function is second degree polynomial. Function is of degree 2. So we have to write up to d square terms, because higher order derivative d cube d power 4 will be 0. So in this expansion, wherever you get d square terms, stop it there. So let us write 1 minus d. D means what? D square minus 3d by 2 plus d square, that is d square minus 3d by 2 whole square into x square. So multiply each and every term. So this is 1 into x square is x square minus 1 by 2 into d square of x square is 2 minus 3 into derivative of x square is 2x plus 1 by 4 into, you expand this numerator, d square minus 3d whole square. What you will get? That is d power 4 plus 9d square minus 6d cube of x square. 4 times derivative of x square is 0. 6 times derivative of x square is 0. Only we get this term. So 9 into d square of x square means 2 times derivative of x square, that is 2. So this is the particular integral. So therefore the general solution is y is equal to yc plus yp. What is the yc complementary function? c1 e power x plus c2 e power 2x plus x square minus 1 by 2 into x square minus 1 by 2 into, if you take 2 common, this is 1 minus 3x, 1 minus 3x plus 2 ones, 2 twos, 9 by 2. This is how we write the general solution, right? Next, let us see the right side term is of type e power ax into some function of x, that is type 4. So if this function is the given equation in the form of f of d into y is equal to e power ax into v. V means any function of x, x square or sin x or cos x or any function of x. So we write e power x, so 1 by f of d into e power x into v means we write e power x first then replace d with d plus a into v. Now this will be converted into previous any one of the two methods. Now let us see this. First of all, this can be written as f of, this is in the form of f of d into y is equal to 8 e power 3x sin 2x, right? So what is the auxiliary equation? F of m equal to 0. So this can be written as m square minus 6m plus 13 equal to 0. So there are two roots for this, minus b plus or minus under root of b square minus 4ac by 2a. So this is 36 minus 52 is 16, minus 16 is 4i divided by 2. So we got complex roots which is given by 3 plus or minus 2i. So alpha is 3, beta is 2. So what is the complementary function yc? E power alpha x, that is e power 3x c1 cos 2x plus c2 sin 2x. Now let us find the particular integral yp. 1 by d square minus 6d plus 13, the function is 8 e power 3x sin 2x. Now e power ax into any function of x. So here v is sin 2x. So let us take e power 3x outside. 8 e power 3x into, just replace d with d plus a. A means what? 3. So in place of d, write down 3. So we get d plus 3 whole square minus 6 into d plus 3 plus 13, and the function is sin 2x. So if you solve this, what you'll get? Denominator value d square plus 9 plus 6d minus 6d minus 18 plus 13. So this is plus 6d minus 6d cancel. 9 plus 13 is 22, minus 18 is d square plus 4. So this is 8 e power 3x 1 by d square plus 4 into sin 2x. So now this is of type 2, sin ax, sin bx or cos bx. The function is of, this is of type 2. So we have to substitute d square equal to minus 4. But if you get d square equal to minus 4 in the denominator, it will be getting 0. So in the failure case, we have the different formula. So the formula is, the function is sin, so minus x by 2b cos bx. Here minus x by 2 into, what is b value? Sin 2x means b equal to 2. So b equal to 2 cos 2x. Therefore this is only yp, particular solution. Now general solution is y equal to yc plus yp. What is yc? E power 3x into c1 cos 2x plus c2 sin 2x plus x cos 2x divided by 4. This is the particular integral. So write down yc plus yp. Thank you.